Have you ever wondered that why lemon tastes sour? Or when we touch soap, why it feels slippery? Or is there only one type of salt? We'll explore all these concepts in Science chapter number 5, Acid, Bases and Salt.
What are acid, bases, and salts? Acid, base, or salt क्या है? These are three chemical groups. Acid, bases, and salts are common type of substances. They show different properties in water and reaction. Acid, bases, and salts अलग अलग तरह की प्रॉपर्टीज शो करते हैं और इनके रिएक्शंस भी अलग अलग होते हैं. Why they matter? Used in food, cleaning, medicine, and industrial process. Help explain reaction in lab and in nature. What will we learn next? How to identify them using indicator and pH scale. How acid and bases form salt by neutralization. Acids, nature and properties. What is an acid? Acid produces H plus ions in water, pH usually below 7. Acids are sour in taste, and always remember, never taste chemical in labs. Some reactions. When acid react with metal, they form salt and hydrogen gas, and when acid react with carbonates, they form salt, carbon dioxide and water. Some everyday examples. In lemon, we have citric acid, curd contains lactic acid, and vinegar contains acetic acid. In the same way, antacid have formic acid and oranges have citric acid. Lab and household acids, hydrochloric acid, sulfuric acid, nitric acid, which are used in labs and industry. Battery acid is dilute sulfuric acid, and we should always handle it with care. Bases. What makes them unique? What is a base? Substances that produce OH negative ions in water is a base. It neutralizes acids to form salt and water. Typical property: bases are bitter in taste, soapy, slippery feel on skin, turns red litmus blue, and pH is more than 7. Some common examples: in home, we get soap, detergent, baking soda, milk of magnesia, and in lab, sodium hydroxide that is NaOH, calcium hydroxide that is lime water. Salts, the result of reaction. We will get to know how salts are formed. Made when an acid reacts with base, it is also called as neutralization. Products are salt and water and often less corrosive. Common example: table salt that is sodium chloride NaCl, baking soda NaHCO3, and washing soda Na2CO3. Why salt matters? Used for seasoning, preservation, and electrolyte balance. In industry, it is used in fertilizer manufacturing, glass, straw, and for water treatment. Indicators detecting acid and base. What is an indicator? A dye that changes color with acid or bases. It helps identify solution without tasting or touching, which is very important. Litmus paper. It is a common test. In acid, blue litmus turns red, and in bases, red litmus turns blue. Natural indicator. Turmeric and China rose are examples of some natural indicator. The pH scale, measuring acidity. What pH means? pH shows how acidic or basic a solution is. It usually ranges from 0 to 14 in school chemistry. Reading the number: pH less than 7 is acidic, pH equals to 7 is neutral, and pH more than 7 is basic. Lower the pH, stronger the acid; higher the pH, stronger the basicity. Everyday pH examples. Here are some examples. Lemon juice is approximately 2, vinegar is 3, pure water is neutral, baking soda is approximately 8 to 9, soap is 10, and bleach is approximately 12 to 13. These examples show us that lemon juice and vinegar are acidic, pure water is neutral, and baking soda, soap, and bleach are basic. Acid base reaction. Neutralization. What is neutralization? An acid react with a base to reduce acidity. Product formed are salt and water. General reaction. When acid react with base, it gives us salt and water. For example, when HCl, that is hydrochloric acid, reacts with NaOH, that is sodium hydroxide, it gives us NaCl, that is sodium chloride, which is our common salt, and H2O, which is water. Why it matters? pH moves towards 7, making solution less corrosive. Heat may be released, reaction can be exothermic. Real life example, antacids neutralizes excessive stomach acid and liming acidic soil. Use CaO or COH twice to raise pH. Some everyday use of acids. Acids are used in food and drink. For example, vinegar adds sour taste, helps in preservation. It contains acetic acid. Citric acid in lemon softens flavor, acts as a preservative. Cleaning at home, industry and lab, and safety first. Always remember, wear goggles, handle dilute acids, and avoid skin contact. Always add acid to water, flush pills with water. Everyday uses of bases. It is used for cleaning power. It is also used at home and in medicine. And always remember, safe handling is very important. Salts in daily life, food and preservation. Table salt adds taste, helps to preserve food. Farming and soil. Fertilizer salt supply NPK, that is nitrogen, phosphorus, and potassium for plant growth. Industrial and daily products. Na2CO3 help making glass, soap, and detergent. And health connection. Body fluid needs salt for nerves and muscle action. Some natural source of acid and base. Acid in fruit and food. Lemon, orange contain citric acid, which gives a sour taste. Natural bases around us. Lime water, that is COH twice, is basic, used in whitewashing. Mineral and rocks as source. Limestone, chalk, CaCO3 are basic carbonates in nature. And everyday connection. Baking soda, which is a mild base, neutralizes acids in cooking. Acid bases and salts in environment. Soil chemistry balance. Low pH leaches calcium and magnesium, which reduces fertility. Liming with CaCO3 raises pH, which improves nutrient. Water and aquatic life. Acidic water increases metal ions, harming fish gills. Buffer of HCO3 and CO3 keeps lake near pH from 6.5 to 8.5. Air acid rain pathway. SO2 and NO2 from acids rain pH can drop to 5.6 or below. Damage leaf, soil, and limestone building CaCO3. Chemistry solution. Fuel gas desulfurization uses CaO and CaCO3 to trap SO2. Key takeaway and next step. Core idea. Acid releases H plus in water and bases releases OH negative. Neutralization forms salt and water and many daily uses. Tools to identify. Indicator changes color. Litmus and natural indicator help. pH scale ranges from 0 to 14. 7 is neutral, below 7 is acidic, and above 7 is basic. Think like a scientist. You can predict outcome. Acid plus metal, acid plus base, and acid plus carbonate. Relate chemistry to food, cleaning, soil, and water, safe and responsible. Wear a goggle, add acid to water, never reverse. Label, store properly, and dispose as instructed by teacher. Thank you.